All right, we've been working with approximating square roots in class. We've already worked with one method, the long division method. Today we're going to learn another method, and this one can be a little more accurate, so sometimes it's important to be able to use this method as well. It's called guess and check. So this is approximating square roots part 2. Our lesson objective is I can give decimal estimations of irrational numbers. It's the same objective we've had for the past few days where, remember, each square root that's not a perfect square is an irrational number. So these square roots that we're doing are irrational, but we're going to write an estimation for them, a decimal that ends, because you can't write the whole thing, it goes on and on forever. So our introductory problem here says Aaron has a square front yard with an area of 57 square yards. He wants to put in a sidewalk on one side of his yard. How long does the sidewalk need to be? So we've talked about in class, if you know the area of a square, to find the length of one side, you just take the square root. So we'll be taking the square root of 57. This will be the example problem we work our way through here in the step-by-step boxes. I'd like you to go ahead and take a minute, if you haven't already, to go ahead and fill in the square roots and perfect squares again. This is something we've done a few times already, but I want you to write them down on these notes also, just to continue to keep working on memorizing those. So stop the video real quick if you haven't done that yet and fill those in. Let's take a look at these step-by-step boxes here. We're going to find the square root of 57 to help Aaron figure out how long his sidewalk will need to be. So these first couple steps are exactly the same as what we did with the long division method. Write the two perfect squares on either side of 57 and write their square roots. So we're going to go ahead and write 57. The two perfect squares on either side of 57 are 49 on the low side and 64. That's greater than 57. So we'll take the square roots of those, show the square roots for all of these. Square root of 49 is 7. Square root of 64 is 8. So we're on to number 2 here. The whole number of your answer is the square root of the smaller perfect square, just like last time. So this is still, going up through step number 2, this is still the same. So I'm going to rewrite what we've done so far. You do this too. Square root of 49 is 7, square root of 64 is 8. So we know that our answer is between 7 and 8. So it's going to be 7 something. So go ahead and write that, 7. But we're going to write this as a decimal, so go ahead and put a decimal point here. We're not writing a fraction this time. This is where things get different. So let's go ahead and we're not going to rewrite what we've done so far here on step number 3. What we're going to do is we're going to guess the square root of 57 to the nearest tenth based on where it is between the two perfect squares. So in other words, we know it's going to be 7 point something. And so we think about, is 57 closer to 49 or is it closer to 64? And you don't have to do this, but one thing you could do is write how far away it is from each of these. So from 49, it's 8 away. Right? From 49 to 57, we go up 8. And from 64, we're just 7 away. So we think about which one of the two perfect squares it's closer to and how close. So those are the two sort of questions we can ask ourselves. And really, it's almost halfway between these two, isn't it? I mean, it's only 8 away from this one and 7 away from that one. So maybe a good guess to start off with would be, well, I don't know, maybe it's because it's closer to 64. Let's go ahead and say because it's just a little closer than 64. Instead of 7.5, let's go one more than that. Let's say 7.6 is our estimate. So we're just gonna estimate something just based on how close we think it is. But now we have to check to see if that estimate is a good estimate or not. So we're going to check our guess by multiplying this number, 7.6, times itself. Because when you take the square root of something, you're saying that this is the number times itself that equals 57. So now we're going to test out to see if that's true. So we're going to take 7.6 times 7.6 to see how close we get to 57. So that's going to be the next thing here on number 4. On step number 4 is to multiply 7.6 times 7.6. Set up this multiplication here. Okay, if you haven't done double-digit multiplication in a while, here's a couple things you need to keep in mind. We always start over here on the far right side, and we multiply the 6 times both numbers, and then we're going to go down here and start and multiply the 7 times both numbers. Okay, so 6 times 6 is 36. 6 goes down here, 3 goes up there. 6 times 7 is 42, and then we add in the 3 there. 42 plus 3 is 45. Now when we do the multiplication for 7 here, we need to make sure we write our answers underneath the 7. So sometimes we go ahead and fill in a 0 here to make sure that we write our first number in this spot and not in that spot. So we're going to multiply 7 times both of these. 7 times 6 is 42. So we're going to erase this 3 and put a 4 there. 7 times 7 is 49. 49 plus the 4 is 53. So 6 times all those was 456, and then the 7, really it was 70 times these things because of the place value there, was 5,320. So we combine those together to see what the total was with both of those being multiplied. So we add our two rows together here. 6 plus 0 is 6. 5 plus 2 is 7. 4 plus 3 is 7. And 5 plus nothing is 5. And then you got to make sure you put your decimal in the right spot. For multiplying, the rule is however many numbers you have after the decimal and both of your numbers combined, that's how many digits are after the decimal in your answer. So there was one number after the decimal here, one number after the decimal here, so two numbers after the decimal altogether. So we're going to should be two numbers after the decimal in our final answer. So 57.76. That's a pretty good estimate. Remember, we were shooting for 57. But it's not quite close enough to say for sure that that's the best estimate. The rule that I want you to go by is it has to be within 0.5, and this is plus 0.76 beyond 57. So because we were too much, we're going to go ahead and lower our estimate this time. It says make another guess if it's not very close, within 0.5 of 57. So instead of 7.6 this time, we're going to do another estimate of 7.5. That's our new guess. So we're going to check this answer by, again, multiplying 7.5 times itself. And then we can see which one was closer to 57. So let's do 7.5 times 7.5. All right, start down here on the far right and do 5 times both of these. 5 times 5 is 25. 5 times 7 is 35, plus 2 is 37. Okay, now we're really taking 70 times both of these, so fill in a 0 to make sure we put our numbers in the right spot here. 7 times 5 is 35. And 7 times 7, or 70 times 70 is really what this is. But 7 times 7 is 49. 49 plus 3 is 52. So now let's add these and see what we got. So 5 plus 0 is 5. 7 plus 5 is 12. Regroup to 1. 1 plus 3 plus 2 is 6. And 5 plus nothing is 5. So we get 56.25. And remember, we were shooting for 50. Oh, we got to move these decimal and put the decimal in the right spot. So there's two numbers after the decimal here. So once again, we'll do two numbers after the decimal. So remember, we're shooting for 57. So we were under 57. If we're at 56.25, how much more do we need to go to get to 57? We need 0.75. So that means we're 0.75 below where we need to be. So this one was 0.76 above, this was 0.75 below. We're just looking for the one that is closest, the best estimate between those two. They're very close to being the same estimate. But because this is only 0.75 away and this is only 0.76 away, this is going to be the better estimate of 7.5. The nice thing about this method is we could keep going beyond just the 7.5. Because 7.5 and 7.6 were so close to each other, it was really about halfway between those two estimates. We could make another estimate of 7.5 and then go to the hundredths place and say 7.55. And we could actually multiply that and get even closer with our estimates. We go to the hundredths place or even the thousandths place. And that's what this method has the advantage over the other one of long division, of being able to get more and more accurate estimates. If you add more and more numbers after the decimal and continue to check how close can we get to 57. But today we're just going to go to the nearest tenth. So let's do a couple more together here. Let's do the square root of 22. Let's practice this method a little bit. So again, the steps are the same to begin with here, and I'll try to remind you here of these steps, but the 1 and 2 are the same as what we've been doing in class. You just write the two square roots on either side of the number. So the two square roots on either side of 22 are 16 and 25. Take the square roots of those. The square root of 16 is 4. The square root of 25 is 5. So again, we know our answer will be between 4 and 5. So we're going to write 4 point. Now this is the point in which we're trying to find a good estimate, something that we think is good. So we're just going to guess something and then check it. But let's make an educated guess here. Is 22 closer to 16 or closer to 25? Well, it's only 3 away from 25, but it's 6 away from 16. So it's definitely closer to 5. So we want something more than 4.5. It's not just right at 4.5, so it's not going to be 4.5. And maybe even more than 4.6. 4.7 might be a pretty good guess. Let's try 4.6 and see how that goes. Okay, so we're gonna use an estimate of 4.6. So we'll do 4.6 times 4.6 and see how we come out with that. So do this multiplication with me here. 6 times 6 is 36. So 6. And put the 3 there. 6 times 4 is 24. 24 plus 3 is 27. Okay, and we'll multiply the 4 times the 6 and the 4 times the 4. But we're going to put a 0 here to make sure we get these in the right spot. So 4 times 6 is 24. 4 there. Can erase the 3 there and make it a 2. And 4 times 4 is 16. 16 plus 2 is 18. So now we add this together and see how close we get to 22. 6 plus 0 is 6. I'll move this up a little bit here. 7 plus 4 is 11. 1 plus 2 plus 8 is also 11. And 1 plus 1 is 2. There are 2 numbers after the decimal in our question, so 2 numbers after the decimal answer. 21.16. That's pretty good. It's pretty close to 22. But it's a little short of 22, so we might want to move it up, and it's not so close we can say we're done. Sometimes, if after just one guess, you can say that's close enough. I think we've got it. But on this one, I don't think we are. So we're going to go ahead and try 4.7. Let's see how close we get to 22 with this. So 7 times 7 is 49. 7 times 4 is 28. 28 plus the 4 we grouped is 32. Then we're going to multiply the 4 times the 7 and the 4 times the 4. So 4 times 7 is, we'll make sure we put a 0 in here. I keep forgetting to do that. 4 times 7 is 28. We group the 2 there. And then 4 times 4 is 16. 16 plus 2 is 18. Let's see what we got this time. 9 plus 0 is 9. 2 plus 8 is 10. 1 plus 3 plus 8 is 12. And 1 plus 1 is 2. 2 numbers after the decimal. So 2 numbers after the decimal answer. 22.09. Wow, that's really close. We're just 9/100ths away from 22. If we had done 4.7 in the first place, we probably could have just stopped there because that's a really good estimate. So the square root, remember this is not our answer. We're just checking to see how close we are to 22. The actual answer is the better estimate, which was 4.7. All right? Let's just do one more here, and then we'll do some more in class. Let's do the square root of 50. All right, so we got 50. The 2 square roots on either side are 49. 49 is just 1 away from 50, and 64. So this was like the same in our example problem that we did, isn't it? The 2 square roots are the same. So take the square root of each side. Square root of 49 is 7. Square root of 64 is 8. So this is going to be between 7 and 8. It's going to be 7 something. Now, if you take a look at this one, it's pretty easy to tell which one we're closer to, right? We're only 1 away from the 49, but we're 14 away from the 64. We're so close to the 49, just 1 away, that it really doesn't make any sense to do anything besides just a little bit beyond 7. Probably 7.1 is going to be a good place to start to see where we're at there. So let's do 7.1 times 7.1. Let's check to see how that looks. So 1 times 1 is 1. 1 times 7 is 7. Well, that's pretty easy. Go ahead and put a 0 here. 7 times 1 is 7. And 7 times 7 is 49. So add quite a bit there. Let's add this up and see how close we are. Remember, we're shooting for 50. Okay? The 1 plus 0 is 1. 7 plus 7 is 14. Group the 1 there. 1 plus 9 is 10. And 1 plus 4 is 5. We got two numbers after the decimal, so put that there. 50.41, and that's even a little bit high. So, but we're within 0.5, aren't we? 0.41 is within 0.5 there of that answer. So we don't really have to guess again if we're within 0.5. 7.1 is going to be your best estimate. If we were to estimate something else, it would be less than that. It would be 7.0, and I don't think that's going to be your best estimate. We know what 7.0 times 7.0 is. It's 49, right? 7 times 7 is 49. So that's not going to work. That's going to be too far away from that. So 7.1 is your best estimate for that one. We don't have to guess again. All right, we'll do more in class.